Hi guys, my name is Zihao.
And I'm Yuheng.
Today we're going to have a presentation about multi-hop question answering. So let's get started now. First of all, I'd like to present a brief introduction to this topic. What is multi-hop question answering? Well, you can imagine that you have designed a smart robot which is able to answer any question you may ask. But how does the underlying system gather information about the answer? Sometimes your question is explicitly resolved by a document in the database. In that case, you simply search for that particular sentence or paragraph and return the answer to the client. But most of the time, an accurate answer may consist of information pieces from different parts of a document or even different documents. So simply speaking, multi-hop question answering requires a model to be capable of collecting information from different text sources and effectively deriving the answer from those information. As an example here, suppose we want to ask our smart robot whether British Shorthair is able to swim. Here we find two useful text sources. The first one suggests that British Shorthair is a kind of domestic cat, and with that information in hand, we continue searching, and finally, from this piece of information, we learned that domestic cats are born physically able to swim. So perfect. Now we can safely derive the answer that British Shorthair can actually swim. So we return the answer to our client. Now we can ask, why do we concern about multi-hop question answering? Well, first of all, based on this technique, we can design a powerful and efficient question answering system. There are lots of situations in which an automatic query service may come in handy. With the help of this technique, computers are more competent to take the place of human and provide better services. Another application turns out to be associated with search engines. I believe we have all experienced a situation that the search results don't effectively address our question, or it just gives a bunch of documents and we have to dive into those information to find out the answer. That is annoying, and sometimes it's simply because the search engine cannot make connections between different text pieces. Therefore, with the help of multi-hop question answering, there could be another huge boost on the performance of our search engines. Now, Yuheng will talk about some current progress in solving multi-hop question answering.
Okay, so basically there are two main popular ways to approach this problem. The first one is called the retrieve plus read system. What it does is that it first runs the standard search engine on the question, gathers all the relevant documents, and then uses a deep neural network to find the sequence of documents that together forms the answer, just like Zihao's example. Well, the problem for this approach is that the capability of the algorithm might be restricted by the capability of the original search engine, since it might not produce all the relevant information in the search result at the first time. So in his example, it might be the case that the original question does not contain anything about a web page that talks about domestic cats. So this web page that actually contains the right answer might be left out from in the first round of search. Now, an alternative approach is to use something called a knowledge base, or shortly KB. So KB is just an abstract graphical data structure that shows the object and the relationships by its nodes and edges in some efficient way. And this algorithm first transforms each text into the knowledge base by using information extraction pipelines. Therefore, if we have a sufficiently large knowledge base, we can just answer every query by traversing edges in some efficient way in the knowledge base. However, constructing such knowledge base is a long time process. It requires many samples and many previous queries to finally construct a useful KB, and this will often result in inefficiencies. For example, there are tons of web pages that are created every day. And whenever we encounter some new web page that appears in some search result, we have to add the web page into the KB. and this may take a lot of time. In addition, real-world problems are often too specified or too complicated or too detailed to be fully contained in a predefined KB. Therefore, KBs are usually not that complete in real-world application.
Okay. So besides those attempts in this area, people have also designed several handy tools or models that facilitate the research of multi-hop question answering. So here, the first category is testing tools and data sets for personal implementations. Hoppa QA is a platform designed intentionally for multi-hop question answering model testing. Once researchers have designed and completed their model, they can submit their work to the web and use the provided evaluation script to evaluate their performance. In the distractor setting, a question answering system must read 10 paragraphs to provide an answer to the question, and they also need to justify their answers with supporting facts. So researchers from CMU are also involved in the development of Hoppa QA. And the second category contains more general tools for NLP research, for instance, the BRT model developed by Google. It is a cutting-edge language modeling that applies a bidirectional training of transformer. The creative part of this model is that, in contrast to previous efforts, which looks at a text sequence either from left to right or right to left, it reads the entire sequence of words at once. So it is bidirectional and allows the model to learn the context of a word based on all of its surroundings. Some recent research in multi-hop question answering has adopted this model and potentially achieved state-of-the-art performance in this field.
So here are some future research directions in the field of multi-hop question answering. First of all, query-dependent embeddings typically and empirically shows higher performance. Therefore, reducing the proportion of the KB that are independent of the queries could lead to great speed up. In addition, for any pipeline method, the precision of the classifier greatly governs the overall performance. Therefore, scientists are working to either improve the classifier or to better train the model from scratch with a larger context to remove the dependence on the classifier. And last but not least, a fast operation for traversing the edges in the KB graph is also desirable in order to achieve better efficiency and precision. In fact, it might be possible to do the traversal in the scale of, say, the entire Wikipedia in milliseconds in a few years or decades. And here are some references for our presentation. And this will be all for our sharing today. Thank you everyone for your listening.
Yeah, thanks for watching.